So ask your remaining people to join the class as soon as possible. Okay. So today we are going to study a simple theory. Okay. So we are actually learning about the columns. Okay. Columns in compression. Okay. So generally column means it is meant to carry a compressive load. Okay. So there is a particular theory that is related to the collapse of the column. Okay. So we'll see the column. So okay, so today we are going to study a theory that is related to limit state of collapse. So we already learned about what is a limit state and its different criteria. Okay, so today we'll learn about how a limit state of collapse is occurring when in compression. Okay, so usually in column you are having a compressive force. Okay, usually in columns you're always having a compressive force. Okay, so limit state of collapse and the assumptions. So this theory എന്ന് വെച്ചാൽ this is actually dealing with ഒരു column. ആ column compressive load വരുമ്പം എങ്ങനെയാണ് collapse ആവുന്നത്. Okay, so that's what we are uh, uh, studying here. Okay, so you're having certain assumption here. First assumption is that the maximum compressive strain in the concrete in the axial compression is 0.002. Okay, so the maximum compressive strain. Okay, for example, if I'm telling you, one second. Okay, so for example, if this is the column, okay, so this is the column. Okay, so usually this column will be failing like this, that is buckling very much, that is when the compressive load is acting. So how compressive load is acting, this will be like this. Okay, so this is how a compressive load is acting on a column. So when a compressive load is acting on a column, the column will usually buckle like this. So this is a deflected shape of the column, or you can say this is the buckled shape of this column. Okay, so maximum compressive strain, okay, maximum compressive strain in a concrete during the axial compression. So right now we can say that the compression that is occurring is an axial compression. Axial എന്താണ് എന്താണ് ആക്സിൽ എന്ന് വെച്ചാൽ കറക്റ്റ് സെൻറ്ററിലൂടെ ലോഡ് പാസ് ചെയ്യുന്നത്. ഓക്കെ, അപ്പോൾ ഇങ്ങനെ ഒരു ആക്സിൽ ലോഡ് കൊടുത്തു കഴിഞ്ഞാൽ ഓക്കെ, when the axial load is when there is an axial load, okay, when there is an axial load like this, the column will be compressing, the column will be having a deflected shape like this. Okay, so the maximum strain value is 0.002. Maximum strain value that is 0.002. Okay, so please make a note on that. Second, notice that the maximum compressive strain at a highly compressed extreme fiber in concrete subjected to axial compression and bending when there is no tension on the section shall be 0.0035 minus 0.75 strain at the least compressed extreme fiber. Okay, so maximum compressive strain at highly compressed extreme fibers. Okay, അതായത് നമ്മൾ for example if you're taking a column like this, okay, so if this is a column, okay, so ഈ കോളത്തിനകത്ത് if the load is applied like this, okay, we can say that ഏറ്റവും കൂടുതൽ സ്ട്രെയിൻ വരുന്നത് എവിടെയാണ്, മാക്സിമം വേറെ ഒരു മാക്സിമം സ്ട്രെയിൻ ഒക്കെ ഡെഫിനറ്റ്ലി ഇങ്ങനെ ഇത് occur ഇങ്ങനെ ബെൻഡ് ചെയ്ത് കഴിഞ്ഞാൽ മാക്സിമം സ്ട്രെയിൻ വിൽ ബി ദിസ് മിഡിൽ പോർഷൻ അല്ലേ. മാക്സിമം സ്ട്രെയിൻ വിൽ ബി അറ്റ് ദിസ് പോർഷൻ. ഇതാണ് ഏറ്റവും കൂടുതൽ ബെൻഡ് ചെയ്തിട്ടുള്ളത്. So the maximum, that is maximum compressive strain at highly compressed extreme fibers. Okay, so then the extreme fibers you will be having the maximum compressive strain. Okay, so there the value is 0.035 minus 0.75 strain at the least compressed extreme fibers. Okay, ഇങ്ങനെ compress if the load is applied the column will be buckled like this. അപ്പോൾ ഇങ്ങനെ ബക്കിൾ ചെയ്യുന്ന സമയത്ത് maximum compressive strain at the extreme fibers, അത് ഏറ്റവും കൂടുതൽ maximum strain വരുന്ന ഒരു portion it will be here. ഓക്കെ, സോ ഇവിടുത്തെ എക്സ്ട്രീം ഫൈബേഴ്സിൽ പുറത്തുള്ള എക്സ്ട്രീം ഫൈബേഴ്സിലായിരിക്കും ഏറ്റവും കൂടുതൽ സ്ട്രെയിൻ വരിക. സോ ദ സ്ട്രെയിൻ വാല്യൂ ഇസ് ഈക്വൽ ടു 0.035 മൈനസ് 0.75 സ്ട്രെയിൻ അറ്റ് ദ ലീസ്റ്റ് കംപ്രസ്ഡ് ഫൈബർ. ഓക്കെ, in addition to this, there are some more assumptions are there that is similar to other assumptions, that is for the limit state of collapse, for the flexure and for other limit states also we have studied certain assumptions. First one is that the plane section normal to the axis remains plane after the bending. That means you are taken elastic condition over here. What do you mean by elastic condition? Elastic condition means what? Okay, so here we are assuming that, so here the load has applied. Okay, so forget about this, we'll take a new figure. Okay, so here what is happening that, so this is a column like this. Okay, this is a column like this. Load has been applied, compressive load has been applied. So what as a result of this applied load, the column will be buckled like this. Okay, the column will have a buckled ingane column ഒന്ന് bend ചെയ്യും. Okay, column will be buckling like this. Okay, now after the load has been released, okay, so once the load has been released, അതായത് the load that is applied, you are releasing it. Okay, the load has been applied, the applied load you are releasing it. So what will happen, the bend shape it will be regain its initial position, that is same like elastic. Okay, but like or elastic theory, how you are assuming is elastic theory. Elastic theory means when the load is applied, the object will be deformed, and once the load has been removed, the object will regain its position. So same here, the plane sections normal to the axis remains plane after the bending. Okay, it will be remaining plane after the bending also. ഓക്കെ, അപ്പം ബെൻഡിങ്ങിന് ശേഷവും അതെന്തായിരിക്കും, പ്ലെയിൻ സെക്ഷൻ ബെൻഡിങ് ആയിട്ട് മീൻസ് പ്ലെയിൻ ആയിട്ട് നിൽക്കും. Okay, so once the load has applied, it has bent, and after the bending, when the load is removed, it will remain plane itself. Next is maximum compressive strain. The outermost compression fiber is taken as 0.0035 in bending. Okay, so ഒരു കോളത്തിനകത്ത് for example what will happen, biaxial loading is occurring. I have shown you the uniaxial loading, biaxial loading and axial loading. Okay, so in case of a biaxial loading, what is happening, the bending is occurring. Okay, biaxial loading വരുമ്പോൾ what is happening, the bending will occur. Okay, so in such cases the maximum strain in the concrete will be 0.0035 in the outermost compression fiber. Okay, outermost fiber maximum strain value will be 0.0035 in bending. That means in case of a biaxial bending, in case of biaxial bending, what is happening, there will be a bending. Okay, in case of a biaxial bending, when the load is applied biaxially, there will be a bending. Okay, so biaxial endana, uniaxial endana, what is axial loading, these three I have explained to you. Okay, so next is the relationship between the compressive stress Okay, the relationship between the compressive stress distribution in the concrete and the strain in the concrete may be assumed to be rectangular, trapezoidal, parabola, or any other shape which result in the prediction of the strength insubstantial to the agreement with the results of the test. Okay, so that's a compressive stress in the diagram. Okay, the stress strain diagram, it may be rectangular, it may be trapezoidal, it may be parabola, or any other shape. Okay, stress strain diagram. Last one is that, not last one, the acceptable strain value curve is given in the IS code IS 456 2000, and for the design purpose the compressive strength of the concrete shall be assumed to be 0.67 times the compressive strength characteristic strength. The partial safety factor y 1.5 shall be applied to this. Okay, with the same one, same like this two, there is point 5 and point 6 is similar to that we have studied in limit state of collapse for flexure. Okay, so same thing ആണ് അവിടെ വരുന്നത്. Okay, and this both is available in the IS code also. Okay, I have explained the stress strain diagram in the first module. I have explained you with the figure. Okay, with the figure I have explained to you how the factor of safety is applied, how the 0.67 is applied. Okay, so that same thing is coming for column also, there is no difference. Okay, module 1 for the beams I have explained you the stress strain diagram, so that two portions അത് തന്നെയാണ് സെയിം ഇവിടെയും വരുന്നത്, വ്യത്യാസമൊന്നുമില്ല. Okay, next is that the tensile strength of concrete is ignored also. Okay, so here we are dealing with compressive force. So tensile strength will be ignored here because the tensile strength over here will be very small value. So you don't have to take care of it. It will be ignored. Okay. So here we are taking care about the compressive value. We are dealing with the column. So column the major load will be compressive force. So tensile strength is ignored. We are not calculating it. Next is the stress and the reinforcements are derived from the representative stress strain curve for the type of steel used. Typical curves are given the IS 456 2000. For the design purpose, the partial safety factor equal to 1.15 shall be applied. Okay, so same like beams also. ഇവിടെ നമ്മൾ stress strain diagram. Okay, we are having steel we are having a separate stress strain diagram and stress strain diagram, that is for each grade of concrete, that is for FE 250, FE 450 and FE 500. We are having a stress strain diagram. Our stress strain diagram you will be taking the values, will be taking the respective values. Okay, and from the given value you will be applying a partial safety factor of 1.15 for the steel. Okay, അതൊക്കെ എടുത്തിട്ടാണ് നമ്മൾ ഫൈനൽ വാല്യൂ എടുത്തിട്ട് നമ്മൾ ചെയ്യുന്നത്. Okay, so this also we have explained for the module 1 in case of beams. Okay, so this is same. Okay, okay, so this is available in the IS code. Okay, all these things are available in the IS code, that is in clause 39, page number 70 I think. Okay, approximately page number 70. All these clauses all these things are available, you can take a look. Okay, now we can start a problem now. So this is the theory that is related to limit state of collapse in compression. Okay, so before, don't get confused, we have studied about limit state of collapse in flexure, that is in case of bending for the beams. So here we have studied about limit state of collapse, the assumptions that is taken in the limit state of collapse with respect to the compression in columns. Okay, but points almost similar ആണ്, കുറച്ച് ഒന്നോ രണ്ടോ പോയിന്റ്സ് മാത്രം അവിടെ ഇവിടെ മാറ്റുള്ളൂ, ബാക്കി എല്ലാം സിമിലർ ആണ്. Okay, all of you please write down this question now. Design a circular column design design a circular column of diameter 400 mm subjected to a load of 1200 kilonewton. The column is having a spiral ties. I'll tell you what is a spiral ties. The column is 3 meter long, effectively held in position at the both ends, but not restrained against rotation. Use M25 and Fe415 steel. Okay, so please write down the question. Okay, did you write? Is it over? Okay, so എന്താണ് question? What is the question here? They have asked you to design a circular column. Okay, they have asked you to design a circular column which is having a diameter of 400 mm. Okay, so previous problem they have not given the diameter. Okay, problem they have not given the dimension, but this problem they have given you the dimension. So the dimension is given as 400 mm. Okay, so please understand the question first. You'll be having a variety of questions, so you don't get confused. Okay, so previously kind of different data, this is having a diameter. Okay, subjected to a load of 1200 kilonewton. The column is having a spiral ties. Okay, spiral tie. So what is a spiral tie? We'll see. The column is 3 meter long and effectively held in position at both ends, but not restrained against rotation. Okay, so unlike previous, so previous problem they have asked you to design a column. They didn't mention whether it is a square column, whether it is a rectangle, or whether it is circular. Okay, so it is specifically they have not mentioned anything. So the job was very easy for us. So we have assumed as a square column. In this question, they have asked you to design a circular column. Okay, with the spiral ties. So this is a circular column with a spiral ties. Okay, so circular column, the shape will be circle and the lateral ties. Okay, so this is the lateral tie that you are seeing. Okay, this is the lateral tie. The lateral tie that you are seeing. Okay, can you see this? Okay, this lateral tie, that നിങ്ങൾ കാണുന്ന ഈ lateral tie, it is spiral in shape. അതായത് കോളത്തിന് ഇങ്ങനെ ചുറ്റി ചുറ്റിയാണ് എടുക്കുന്നത്. Okay, so this type of column is called as helical reinforcement അല്ലെങ്കിൽ spiral ties. Spiral reinforcement എന്ന് പറയും അല്ലെങ്കിൽ helical reinforcement എന്ന് പറയും. Okay, column with helical reinforcement or spiral ties. Okay, so understand it. So whenever you heard about circular column, first thing that should come your mind that minimum six number of longitudinal bars is provided. Okay, so let's see here. Okay, so one, two, three, four, five, six. Okay, so they have provided minimum number of reinforcement bar over here. Okay, so this is another view. Okay, so this is exactly how you are providing a spiral ties. Okay, reinforcement will be provided like this. Okay, chutti chutti you will be providing the lateral reinforcement. And if you take a cross sectional view, so this is how it will be. Okay, okay, the cross sectional view it will be like this. You can see if you take a plain cross sectional view, front view നമ്മൾ നോക്കി കഴിഞ്ഞാൽ it will be like this. Okay, so these much things you should understand first before going to decide. Okay, so here what we are going to do here, you have to find out the diameter of the longitudinal reinforcement. This is a longitudinal reinforcement. Okay, so how much dia that you have to provide, how much number of longitudinal reinforcement has to be provided, and next the helical reinforcement. Okay, the diameter of this helical reinforcement and the pitch means, see they have mentioned clearly the pitch എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ this is the pitch. Okay, so here the pitch എത്ര ഡിസ്റ്റൻസിലാണ്, at what distance you are uh, spirally tying the reinforcement. Okay, so this is taken as pitch. Okay, so this is taken as pitch. Okay, so at what pitch you have to provide the reinforcement. This much things you should find out, and this should be there in your mind. Okay, now let's go to the problem now. And one more thing they have asked you, that is the column is effectively held in position. Okay, the column that you are designing, that is of 3 meter long, so that is effectively held in position. That means no translatory motion, but not restrained against rotation at the both ends. അതായത് rotation is there at both the ends. Okay, at the both the ends rotation is there. Okay, so what kind of a support it is, can you tell me? It is not restrained against rotation, but it is held in position. But a translatory motion is restrained over here. Okay, the translatory motion അല്ലെങ്കിൽ the horizontal movement is not allowed, but rotation is allowed at the both ends. So what kind of a support it is, can you tell me? Tell me, someone tell me what kind of a support it is. Please refer the IS code, you can understand, no? Refer the IS code, page number 94. IS code, page number 94. What will be the effective length? Okay, the length of this column, അതായത് മൊത്തത്തിലുള്ള floor to floor height is 3 meter long. That is, our column length is 3 meter. What will be the effective length of the column? Tell me. Effective length of the column. IS code page number 94. Please refer. 1. Okay, 1. 1L. Okay, so that means 1 into 3 meters. 3 meters. Effective length of this column is 3 meters. So basically this is a hinged support. Okay, you can say that very hinged support ആണ്, because in hinged support what is happening, ഒരു hinged support എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, okay, hinged support the translatory motions will be blocked, but at the same time the rotation will be allowed. അല്ലെ, hinged എന്ന് പറയുമ്പോൾ rotation is there. Okay, so rotation is allowed. So that's what they have told you. It is effectively held in position. That means രണ്ട് ends translatory motion is not there, but not restrained against rotation, which means rotation is there. Rotation is there means always think, oh, for the hinged support rotation is there. Okay, so that's the hinged support. From the IS code you can find out the value, that is 1 L, that is 1 into 3. The effective length of the column is 3 meters. Okay, now let's go to the problem. First of all, write down all the given data. Okay, first of all of you write down the given data. The given data. First of all, effective length you have find out. Effective length is 1 L, which is 3 meters itself. Next is load has been given. How much is the load? Okay, the load that is given is indicated by P. Okay, so load is 1200 kilonewton. Load is given. Next, diameter of the column. They have already given the diameter, that is 400 mm. Now FCK grade is 25 Newton per mm square, and also Fy is equal to 415 Newton per mm square. So this much of informations are available to us right now. So we can start the design of the spiral columns. So first of all, we'll find out the nature of this column, whether it is a short column or long column. We don't know whether it is a long column or a short column. Okay, but first of all, a long column or short column, we should start the design, because in the question they have not mentioned about any cuts, any such things. Short or long or they have not mentioned any such things. Okay, so short column design is entirely different and long column design is entirely different. Okay, so first of all, find out whether it is a short or long column, the nature of the column. Okay, so step number one, how will you find out? That is by slenderness ratio. Step number one, slenderness ratio. The slenderness ratio is equal to L effective divided by least lateral dimension. So ഇവിടെ least lateral dimension is not there, we are having just a diameter. Okay, so L effective is equal to 3 meter, converting it into mm, 3000 mm divided by 400. So how much it is? 3000 divided by 400. How much it is? Remember, 3000 divided by 400, it is 7.5. Okay, so 3000 divided by 4000, that is 7.5, clearly less than 12. Okay, since it is less than 12, we can write a note that this is a short column. Okay, so we can write a note that this is a short column. Okay, so since it is less than 12, it is a short column. Okay, so you have to write with me. Okay, step number 2. Let's see the eccentricity. Step number 2. Let's find out the eccentricity. Okay, shall I rub now? No, for the eccentricity, so eccentricity, refer page number 42. Okay, page number 42, they have mentioned about the eccentricity. So that is E minimum is equal to, as per the IS code, L divided by 500 plus d divided by 30. അതായത് what does it mean? Okay, if this is the column, okay, if this is the column, this is a center. ഈ സെന്ററിൽ നിന്ന് എത്ര മാറിയിട്ടായിരിക്കും the load will be acting, the minimum distance. Okay, so E minimum will be L by 500 in divide plus D by 30. So L is equal to how much? 3 meters. We don't have any confusion over here. So that is 500 plus D is 400 divided by 30. Tell me the value. How much is the eccentricity minimum? Fast. IS code page number 42. This equation is there. 23.3. Just please check once again. 19.3. Okay, 19.3 is the value. So 19.3 is the value. Okay, now refer to IS code. IS code and the in IS code they have mentioned that a minimum of 20 mm. അതായത് എന്തായാലും ഒരു 20 mm eccentricity ഉണ്ടാവും. That is what IS code is mentioning. Okay, we'll having a eccentricity value minimum of 20 mm. Okay, so there will be a minimum of 20 mm. But this is less than 20. We are having 19.33. Like, okay, this is less than 20 mm. അല്ലേ? So this is less than 20 mm. Okay, so നമുക്കത് accept ചെയ്യാൻ പറ്റില്ല. You have to ignore this value. Okay, this is something like practically impossible thing. Okay, because due to constructional imperfections, അല്ലെങ്കിൽ due to the quality of materials, there will be always an eccentricity at the site. Okay, correct centerlode you will never have the load to pass. Okay, there will be always an eccentricity. So IS code is telling a minimum 20 mm, that is minimum 2 centimeter എന്തായാലും ഉണ്ടാവും. Okay, so here is less than 20 mm, that is 2 centimeter. So which means that you have to ignore this value and you have to go with the IS code value, that is E minimum is equal to 20 mm. You have to take the E minimum value as 20 mm. So ignore the previous value because IS code is telling minimum ഒരു 20 mm ഉണ്ട് എന്നുള്ള രീതിയിൽ വേണം നിങ്ങൾ ഡിസൈൻ ചെയ്യാൻ. Okay, that is what IS code is mentioning you. Minimum ഒരു 20 mm എങ്കിലും ഉണ്ട് എന്നുള്ള ഒരു assumptionൽ വേണം you have to design the problem. Okay, so you have to take it as E minimum as 20 mm. Now again in IS code page number 71 there is another there is something they have related to eccentricity, that's E minimum divided by D should be less than 0.005. Okay, so E minimum is equal to, that is 20 mm divided by 400. So how much you're getting? Like E minimum by divided by D should be less than 0.05. That is as per the IS code page number 71. There is another IS code page number 71. They are mentioning about it. Okay, so it should be less than 0.05. So tell me how much is E minimum divided by D? Fast. 0.05. Exactly 0.05. Okay, exactly 0.05 value ആണ് വരുന്നത്. Okay, so keep it like this. Okay, so let's keep it like this. It means that we are on the borderline. Okay, so just keep it like this. Now coming to the next step, step number 3, you have to find out area of steel. Step number 3, you have to find out the area of steel. So ASC C. Area of steel in compression. You are going to find out the ASC. Okay. So the load that is applied is 1200. Okay, നമ്മുടെ load over the column is 1200 kilonewton. We cannot take anyway this load. You have to take the ultimate അല്ലെങ്കിൽ factored അല്ലെങ്കിൽ design load, that is PU 1200 into 1.5. So how much you're getting? So that will be around 1800 kilonewton. Okay, so the ultimate load അല്ലെങ്കിൽ the design load on the column is 1800 kilonewton. Okay, now coming to the load carrying capacity. Okay, so here we are designing helical reinforcement. Okay, here we are designing the helical reinforcement, അല്ലെങ്കിൽ you can say it is a spiral test. Okay, so you have to refer the IS code again. Okay, so let's refer the IS code again. All of you take the IS code. Page number 71 ആണ്. IS code page number 71 ല് they are mentioning something about spiral ties. How to design a spiral tie. So let's see what they have tell about the IS code. Okay, I think almost time now. Okay, anyway, extendence കൊടുക്കേണ്ട സമയത്തൊക്കെ എല്ലാവരും വന്നിട്ടുണ്ട്. So next class also ഞാൻ തന്നെയാണ് I am continuing. So please read the IS code page number 71. Just ഒന്ന് read ചെയ്യാം. We'll continue the next class and just post your name to mark that.